How does support? This isn't stats, is it? No. Yep. Do you want to talk about differentiability with us? Sure. Donald Trump said we can't do that anymore. Differentials.
He just doesn't remember what it is.
You want to hit him or can I get him? Okay. You finished your test last hour? I feel like your ears pierced.
Yeah. What is this one?
I got an ear piercing kid over there. There's three at a time. Big holes.
Talking about the hole puncher.
Yes. Get back to work, guys.
Alright, so differentiability means differentiate is the same as take the derivative of. So this is like derivative ability. Like differentiable just means you can take the derivative. You are able to differentiate. You are able to take the derivative. And you can in every situation except for 4 spots. So one is if you have a corner like that or a cusp, which would be like that, or this is not a word, but I think you'll know what I mean. Cusp corner, where it's like kind of a combination of them.
That's a sharp turn thing.
What do you mean?
Like when I was reading about it, it said there can't be a sharp turn.
Yeah. So tell me why I can't take. So I would not be able to take the derivative at that point, or that point, or that point. Can anybody tell me why? Yes, Nick.
Because it's like in physics where there's like no meters per second and the turns like you can't calculate it.
Why? That's exactly the same thing, because meters per second is the derivative of position of your meters, and when there's sharp turns you can't calculate it. Why not? Yeah. You already learned it last year, but you're gonna.
I didn't actually.
Oh, then go ahead.
I'm guessing because the slope has an instantaneous change.
Yeah, that's good. So if I asked you for the derivative there, derivative is slope, right? So basically, which would I choose? Would I choose this slope here, or would I choose this slope here? You know, it's just like limits. Like, remember, for the limit to exist, what had to be true about it? It had to be the same for both sides, right? Like the limit from the right and the limit from the left had to be the same. Differentiability is the same thing, except now we're talking about slope. So the slope from the left and the slope from the right have to be the same thing. And if I ask you for the slope at that corner, like I don't even know what I would put. But that's the same thing in physics. Like if this was a meters graph and it went like that, I wouldn't be able to find the velocity right there. If it was rounded, I can do it. If it's a sharp corner, I can't. Yeah.
Is there any way to see one direction, like
We could. It doesn't. We don't really do that because if I wanted to know from one direction, I would just move the point over and be like, okay, what's the slope there? So it doesn't really like apply the same way, but in theory, yeah. So y slope must be the same from both sides. So if you have that sharp turn, it's not. Can I clear that? You want to write that? I'll press it. Give me another condition. Instead of me writing it, you guys can try to come up with a few, or a couple, maybe all. Yeah.
If there's like a jump.
Okay. What do you mean a jump?
Like when the limit approaches 3 and then the limit approaches -3 from the right and the left.
Right.
There's like a jump.
There's a jump. So That's where I was like trying to lead you. So if there's a discontinuity. So a jump is one of the ways it can be discontinuous, right?
Yeah.
Discontinuity. So that could be a jump. That could be a hole. That could be a vertical asymptote. Okay. I think, so I'm like, this tripped me up. I think that vertical asymptote was one of my 4 things, but I'm like, great. Sorry, Steve, we're going to have to Google this for a second. I know the third one, but I can't, I don't know if we already did the 4th one or something.
Yeah, because that was like.
When I did it yesterday on Khan Academy, it said there was only 3.
So I'm thinking there's only 3, and I just used to separate vertical asymptotes for some reason.
Because, like, because it gives you zero. Zero on the bottom.
Well, that's a discontinuity, so.
You're not clear what you're teaching.
Okay. Yeah, there's only 3. I used to teach it as 4, but the 4th one was vertical asymptote, and that's obviously covered under discontinuity. I don't know why that never occurred to me before. So go back to where I said there's 4 ways and change that to a 3. Sure. What else? Last one's hard to think of, but I'll give you a second to try. What does derivative tell us? Slope.
Vertical tangent.
Good. So a vertical tangent line. This is not a vertical asymptote, right? What's a tangent line?
It's like actually just a line, right? It's not like going off in space. It's just like literally a vertical line.
It's like part of your graph is vertical.
Yeah.
So if I have a vertical tangent line, for example, if my graph went like that, this is x equals 2 or whatever, and it's going inside, then it goes straight up and then over. Why would there not be a derivative there?
The slope is undefined.
Derivative tells you slope. Slope is undefined, so therefore the derivative is undefined. So your derivative or your slope are undefined.
Isn't that the same, if not very similar to the vertical asymptote?
No. I mean, it's similar because they're both vertical, but a vertical asymptote, there's just no points there. So what I'm saying for a vertical asymptote is if this is at x equals 3, I can't take the derivative at x equals 3 because there's just not any points there to take the derivative of. Here, we're crashing right through that point. We're just going through vertically, and so our derivative would be undefined. So they're different. Is that fair enough?
Yeah, because I mean, like, because that's like not a function. The tangent line one, wouldn't that not be a function?
Yeah, this is not technically a function either because remember the vertical line test, that's going to pass through like more than one point too. So.
Does it have? I thought there could be a function you still have a tangent line that's vertical.
So that's possible to have a vertical tangent line and a function. It's also possible to have a vertical tangent line. It's not a function. But you could like.
Assuming that all of our problems are functions, or else we could have a whole slew of different rules because it has to be a function to take a derivative too, does not.
So if you get like that, then this could be vertical, but we don't violate that rule.
Are we just assuming that all of our things are functions? Because if it's not a function, there would be another.
So that's true. I shouldn't be going like that vertical. I should be doing more like where it's vertical at one point, kind of, but it never goes straight. We're arguing about like just say derivative. Not derivative. I think you probably figured that out. So then what they do with this, usually on the AP test, is combine it with continuity. And ask you, like, where is it differentiable but not continuous? Where is it just differentiable? Where is it just, like, so they'll kind of throw some of that stuff together. So let's look at something like that.
Are we gonna do more than one example?
It depends if you guys understand the first one now.
I was wondering how much room I know.
Do you have more pages?
Yeah, but I just don't want to take up a whole other page for one. Just my OCD.
It's okay.
Sorry.
So let's say that was f of x. Let's do this. Not differentiable. Not continuous. Both. Or like neither, I guess. Yeah, so that's one of the things I want to talk about. What is it? Is it more difficult for a function to be continuous or to be differentiable? To be differentiable, why? You have to be continuous plus other stuff. So if something is not continuous, it's automatically not differentiable. So as soon as you have a discontinuity, it's both. It's not continuous there. It's not differentiable there either. So let's go through all the spots where it's not differentiable. So x equals, is that a discontinuity, or is that differentiable? Why? Because it's a discontinuity. It's not continuous. Where's the next one as I read left to right? Just shout it. -2, why? Vertical tangent line, so my slope is undefined. Where's the next one? Where? -1, right? It's discontinuity. Next one? 1? Because that's, what is that? What in our three categories, what was it? Discontinuity. It is a vertical asymptote. It's also, I'm just thinking broader. Are there any others? Why? Wilmer, why?
There's a square.
There you go.
Hey, Mr.
Do you know my name?
Yeah.
No, let's hear it. What do you got?
Davis.
Okay. It's like one letter away from your name.
No, so for the very first one at x equals -3,
Yeah.
don't we have a specific point at x equals -3 that would allow us to find the would allow us to find the derivative?
Okay, what's the slope at x equals -3?
There.
Really? How about that?
Well, that doesn't equal there.
Oh, you're saying there's a closed dot?
Yeah.
It's still gotta be the same, like, beyond just like.
Because like the point isn't down there; it's only up there. So we should be taking the derivative at that point.
So if I said like, well, you would need something over here, Juno. If I said like there was a one-sided derivative, you could do that. But if I say just what's the derivative of x equals -3, you still have to look at both sides and consider it, and if the slope isn't
So
the
it's
same.
like the line, if we got rid of the other section, it was just the line, the point. Yeah, that wasn't there. It was just would we still not be able to find the derivative?
No, actually, I'm sorry. Then you could. But if I go to graph this derivative, like with it being like this, what's the slope of this line?
Like negative.
Okay. So your derivative would go like this. The slope of this line is 0, let's say, you can't take the derivative at that corner, so the derivative would look like this, and then if I said, what's the slope of x equals -3, you don't have anything there. So because they don't meet up.
Okay, so if you graph it, there'd still be a hole.
Yes. Other questions? Alright, where is it not continuous? So go left to right. -3, -1, and 1, right? So where's it neither? -3, -1, and 1. So that's the same idea I was trying to say before. What's more difficult to be differentiable or continuous? More difficult to be differentiable because you have to be continuous plus not be what? If you're going to be differentiable, you got to be continuous and not have a sharp corner or a cusp corner or whatever, and not a vertical tangent. So this is neither differentiable nor continuous.
So basically,
The ones that are in both columns, both lists.
But it's not continuous,
so basically all the ones that are.
He's saying that the state that.
If it's not continuous, it's automatically not differentiable. So it's automatically neither. But then these two, this one and this one, are continuous, but they don't fit the qualifications for differentiability because this is a vertical tangent and this is a corner.
Yeah, the word neither must be.
Yeah, I don't know whether to put both or neither. Alright. Is that alright? Should we do another one of those or is that? Yeah, it's fine. Okay. We have time. I'll make it like a little shorter. I don't need my Y values. I don't need no stinking Y values.
Where we're going, we don't need one.
Where we're going, Y values won't help you. So I'll try to phrase this a little bit better. So tell me where it's not differentiable. Tell me where it's not continuous. So answer those 4 questions. One of them is not possible. Before you all start freaking out. So did you guys go read? You guys figure back right? Some of you are not drawing the graphs, so you're like, done already. Some of you are drawing the graphs, so you haven't started yet. So I'm gonna wait until people are done. Some of you are wondering why I'm just sitting here. That's why. Okay, Steve.
very last video.
Did you see what he said in the last one? Insulting.
What?
Every video before, he was like, "This one's great. Thank you so much. You're awesome." And this last one, he was like, "This video was pretty okay. Nothing special. Keep up the okay work."
We have angered the Steven.
It's because you had Steven squared. Like,
I'll tell you, yeah, it's Steven squared plus 3 times Steven.
or plus 2 times Steven. So
Did he comment on our last video?
Yeah.
Does he still comment on all our videos?
Yeah.
Every single one?
Where were you like 20 seconds ago?
Oh my god.
I just said.
I'm totally not here.
He said, like, your video was pretty okay this time. Keep up the okay work. And everyone before, he, like, glowing praise. This time, I must have made it back.
Sorry, Davis, I had a bad day.
That's what I was thinking. Or you didn't like histograms or something. No, it wasn't that. It was the you did a frequency. You do. You already did. Alright.
So he's watching your stats videos now too?
Why not? Maybe not anymore, though, because they're only okay. Hello. I mean, I'm teaching. I'm dropping some knowledge.
Yeah.
Yeah. Alright. Mr. Shin wants to see you after I'm done dropping my knowledge.
Yeah, he saw him once today. What's he got to say? Yeah, it's like,
was it like unresolved?
No.
Was that Mr. Shin that you're talking to?
Yeah.
And you were just like, well, I'm dropping some knowledge?
I'm dropping some knowledge, bro.
Alright.
But I mean,
Give me a volunteer to tell me where this is not differentiable. Oh, this is man. Wilmer, before you leave.
X equals -1.
Why?
Because it's broadcast.
Okay.
X equals 0.
Why?
Because there's a jump.
Okay. Which is a discontinuity, right?
Yeah. And then X equals 1. Because it's the vertical
Vertical what?
tangent line.
Yep.
And then X equals 3. Because there's a corner.
That's what I called it. Alright, you pick someone. Tell me you pick someone else. So you volunteer for her to choose. Tell me where it's not continuous.
It is not continuous at x equals -1.
Why?
Because
No, let me rephrase. What type of discontinuity is that?
it is a vertical x.
Well, yes it is, but that's not a type of discontinuity.
Sorry, it is an essential
Yes.
discontinuity.
Keep going.
At x equals 0,
What kind of discontinuity is that?
it is non-removable.
Or jump, whichever, yeah. And what else?
And at x, oh wait,
that's it.
yeah, that's it.
Yeah.
I wrote x equals
You can erase that column.
Call on somebody. Is that going to bother you?
Yes, it is.
Look at him. He took his glasses off.
Put your glasses on and fix the truth, young man.
You call on someone, Lauren.
David.
Tell me where it is differentiable but not continuous.
Wait, differentiable or not?
Yeah. You know the third question on here?
It's not. Is that a thing?
I'm asking you.
It's not continuous, it can't be differentiable.
Okay, so where is it differentiable but not continuous?
Nowhere.
Yeah. Is this possible ever?
No.
No. This is, I don't know, no salute, not available or
I
something?
just put, yeah, I just put, yeah, Steven, what do you think?
Alright, David, call on somebody.
You.
So Caleb, where is it continuous? This is Caleb. Caleb is
Thank
Caleb.
you, I didn't know his name.
Well, you didn't know mine either. Continuous but,
You're David.
I
It
think
took
we
me a
should all
second.
write our names behind.
where's the last one? Continuous but not differentiable.
I'm gonna screw over everyone's OCD and not go in order. So x equals 3. Oh, that's
Why is it not differentiable?
because there's a cusp corner
Right, and then where's the other one?
at x equals 1.
Okay.
Oh, so.
Questions on this? Is this fine?
Oh, I have a weird question. So will you ever have to explain, like will this ever be part of the response?
Well,
I just don't
so,
know if you can't, like, put cusp corner down.
no, you wouldn't have to
I
ever
just
say
wasn't
this
sure
corner.
if that was like,
Like, you wouldn't really, I don't think I've ever seen them ask you to explain why.
okay.
But within, like, multiple choice, they can kind of make sure you know each little reason
Right.
through the way they put their
I just
answers
wasn't
and
sure if it, like I should be concerned about how to describe this.
stuff. You wouldn't have to say because we're.
Right.
What would you call it then? Like, is there like a?
I would say like the slopes are different from each side.
It's like a spoon.
That's
So
the
it has no actual name. That would be just
not that I care about.
You did define.
Okay. We're going to go through how to do that algebraically also, but I need to show you the shortcut to the derivatives first.
Now my notes are going to be out of order. I don't agree with this.
Oh, stop everything.
I know. Like you couldn't tell this if we're going to go back.
Does anybody know that? So if I have x to the n power, what's the derivative? You learned it though, right?
Yeah.
Anybody else know it? Yeah.
X to the n power. Derivative is n. Or nx.
Are we done there?
Well, it's the first power.
No.
Right?
It's the first power because everyone you've done so far has been to the second power to start with.
It's n minus 1.
It's n minus 1. So if you get, x to the fifth, or y equals x to the fifth, your derivative would be bring down the 5, leave the x there, reduce the power by 1. So that's that whole process you've been doing, like this whole thing here. If you go back and look at that sheet, like the 5 problems that you guys, whichever 5 you did, it takes like 5 seconds. So one of the problems was this, x squared plus 2x plus 3. You guys are over here plugging all that in and cranking it all out, but you don't have to do that. I mean, if I tell you you have to, but what's the derivative of x squared? Bring down the 2, you leave the x, and you decrease the power by 1, so now it's just x to the first. This is like 2x to the first right there. So bring down the 1, multiply by the 2 in front, and then reduce the power by 1, so now it's x to the what? 0, and what's anything to the 0 power? 1, so it's just 2. And also remember this, derivative is slope, right? So if I gave you y equals 2x, what would you tell me the slope is? 2. If I give you y equals 3, what kind of line is that? Forget all this exists. Y equals 3, what kind of line is that? Don't say straight, every freaking line is straight. Flat. Flat's a little better.
Is a
Horizontal, thank you. What's the slope of the horizontal line?
There is
0. So, hold on. Couldn't I write that 3 like that? Isn't that technically the same thing?
really felt the heat.
Bring down the 0, multiply by the 3 in front, what do you get? 0 times who cares? And it's just 0. So you can think about it like 2 ways.
Minus 1 would be it for the
Alright,
first
0 times x to the negative 1. So let's
Wait, why does it who cares? Because it
Because 0 times anything is 0. So when I bring this down, what's 0 times 3? 0. Times, okay, times x to the negative 1, so I gotta reduce the power, but I don't care what's here because what's 0 times anything? So it just goes away.
0 times 2 freaking there.
Or, think about it the way I said the first time. Y equals 3 would be a horizontal line. What's the slope of any horizontal line? Is 0. So either way, you end up with 0. Am I an eraser? Oh, thanks. Derivatives get like way more complicated than this. I mean, we're just scratching the surface here. But this will help us move through the next stuff a little faster. Take the derivative of that. Like our next whole chapter is taking the derivative of all these different ways, different methods, different types of functions. So this is like the very, very basics. Mr. Kegley, what's the derivative of 3x to the third? 9x2?
Or not 9x2, but 2/3 power.
2 to the power?
times the charm. Go ahead.
Killing me. 9x squared is fine.
Sorry, we
Set
did
it.
straight lines and flat lines.
Merch. What about 6x squared?
Well, that
Sislo, negative 4x.
minus.
Logan, negative 8. It's gone. That's my derivative. How many have that?
That's really not.
It's not that confusing, or it is?
Oh, yeah, I got
It's not. Kyle, you got a question, or you just chomping?
It just
You
seems,
didn't raise your hand, Julia.
it seems so like.
What?
You didn't raise your hand, but you got it.
Oh yeah, because I just got it. I was still
Okay,
doing it.
you're good though. Like,
Yeah.
okay. All right. So here's what.
Plug in an x value at any part in that equation. It'll give you the slope at that point.
Yes. Here's what we're using this for right now.
Oh, piecewise.
Piecewise
functions. I love piecewise functions. Yay. Yes, ma'am.
My grandma was a piece of math. She had a piecewise function.
What?
Or what?
Wait, grandmother.
My grandma's dead.
Oh yeah, she shoots squirrels
Yeah,
on the
but I'm
back
just
porch.
like, is this
Like
the
me.
Write that down.
Is this the one that
Right back now.
No.
I didn't do it. You're right. So I gave you these piecewise functions before, and we went through and figured out if they were continuous or not. And if they're continuous, there's those two rows there, right? If they're continuous, what has to be true about the two rows? They gotta be equal. So that's review. Hopefully you remember that. So I'm just gonna go, okay, 1 squared minus 1 equals 0, and then 1 plus 3 equals 4. Those are different, so no, it's not continuous. Do I really need to do any work over here now?
No.
I don't. But, so because once it's not continuous, it's automatically not differentiable. But let me show you what you would do in the case where it came up. You would take the derivative of both of these. So what's the derivative of x squared minus 1?
2x.
And if you plug in 1, it'll tell you the slope at x equals 1. So 2x would turn into 2 times 1, and this top part has a slope of 2. What's the derivative of x plus 3?
Oh, sorry, 1.
It's just 1. So the number in front of the x, like if I gave you y equals 1x, what's the slope? Just 1, right? And then what happens to the 3? It goes away. So the derivative of that piece is just 1. And there's no plugging in, there's no x, so the slope there is 1, and these slopes don't match, so it would be not differentiable. It's not differentiable anyways, because as soon as it's not continuous, it's not differentiable, but I'm just showing you what you do in the case where you had to continue. Let me give you a better example after that. But, questions on this before I move on? Let's say g of x equals 2x plus 3 when x is less than 3, and x squared minus 2 when x is greater than or equal to 3.
Is this supposed to be?
What?
It's not. It's not continuous again. Were you trying to make them continuous?
Yeah. That's fine.
Erase that minus 2.
Thought so.
I did 2 times 3 in my head and got folded. I didn't know what differentiability was. You guys sure you want me to teach this stuff? So, how do I check continuity? Plug in 3 to the top and bottom and see if you get the same thing, and you would, right? Top one gives you 9, the bottom one gives you 9, so yes, it's continuous. So is it possible that it's differentiable? It's possible now, right? Because it has to be continuous first. So like in the last problem, it wasn't even possible. Now that we know it's continuous, let's check and see if it's differentiable. What is the derivative of 2x plus 3?
2.
What is the derivative of x squared?
2x.
If I plug 3 in place of x, but there isn't one, here, what do I get?
2.
I get 2. If I plug 3 in here, what do I get? 6. So your slopes are different. You've got a cusp. You've got a slope of 2 and then a slope of 6. So you get that sharp turn. So is it differentiable?
Nope.
No. Is that right?
See.
So
We get good examples.
I want you to start. Your only homework is there's 2 more of those you can do now. 2 more of the con sections, and you have 11 minutes. I'd like you to start that, so if you get stuck, I can answer your question. But these 2 are what we just talked about. So I'd like you to do those 2. Start them now, and then finish them, later. You might be able to finish them now. I think they'll go pretty quick.
Where are all the
What?
Yes, get out.
where are all the assignments?
Yeah. That one I didn't say due date. The other ones are due Sunday.
Basically, before Monday.
So you told us the 5 that we need to do, and then we just added those. Oh wait, are those 2?
Those 2 are not due Sunday.
Oh.
Saturday
What
is
about
like
the
my day off.
version that would like finish my last.
So only the 5 you assigned
exactly
yesterday?
midnight.
The 5 I told you about yesterday are due Sunday at midnight.
Yes.
This is a separate thing. This is like today's homework. Do that.
I know.
Go. Yeah.
Let's take the 5 that are due Sunday. I feel like I'm that person that finishes it on like midnight.
I feel like if you don't get your homework, it's
I feel like it's not actually allowed to do that.
really just walk in the morning.
I mean, me too. Me too.
You can use your phone.
Wait, so
I can, but it only has like 13% battery.
I don't even get a chance to do this other class.
But we don't have to do it on here. We can go home. So
It's like, what did I do this dog?
You did nothing.
What I did.
Well,
oh yeah, too.
Alright.
What's on yours? Have fun.
good luck. Unless you show all the knowledge. That's border.
Is your day going to be stop recording or is it good?
Oh yeah, I should probably stop recording.
Bye, Stephen.
You guys can hear me